especially honoured and privileged to be here today to celebrate the life, the long, productive life of Andy Benson. And not coincidentally, because when I left Baltimore this morning it was 8 degrees, and I arrived in sunny California it was 73, so I'll take that anytime. Now, I want to begin with a story that's now almost 400 years old, and it was in 1676 that Robert Hooke, who was an English physicist, wrote to Isaac Newton to congratulate him on his scientific accomplishments. And Newton wrote back to him, and he wrote the following words. He wrote, "If I have seen further, it's because I have stood on the shoulders of giants." Now, I don't want to compare myself with Isaac Newton. That would be utterly absurd. But I do want to develop this theme of standing on broad shoulders and seeing further. Now, a substantial part of my scientific career has been devoted to the study of one protein. It's an enzyme. It's now called ribisco, but it wasn't always called that. It's a very important protein. It turns out to be the most abundant protein in the biosphere. And the reason for that is because it has a gargantuan task to perform. It fixes and captures carbon dioxide from the atmosphere in the process, part of the process of photosynthesis. And it does this about 200 billion, that's B with a billion, 200 billion metric tons per year. It's obviously a very important enzyme. Now, I didn't discover ribisco. That was done by Andy Benson some 65 years ago. And not only did he discover this very important enzyme, but he also discovered the molecule with which the carbon dioxide interacts. That was ribulose bisphosphate. Now, this was the culmination of a series of brilliant experiments beginning about 1947. This was in the Lawrence Radiation Laboratory of at UC Berkeley, where the newly discovered isotope of carbon, carbon-14, was employed. Now, up to that point, let me start by saying that when I was an undergraduate some 55 years ago, I studied from, the textbook was a small book, 250 pages, and there were perhaps 4 or 5 biochemical pathways in that book. Now, a biochemical pathway, for those of you who aren't scientists, is simply a series of reactions that occur in the cell where A goes to B, B goes to C, D, E, E, and F, and all the way to X, Y, and Z. Now, as I said, there was only 4 or 5 pathways in that little book. Now, I teach biochemistry now, and the book has grown enormously. There are now 1,200 pages. And the book's also entitled The Principles of Biochemistry. And one of the reasons why it has grown is because now, instead of just 4 biochemical pathways, there are 44 or 54, and that's not counting the ones that didn't make it into the book. Now, who was responsible for all of this? Well, I'm going to tell you that it was Andrew Benson who was responsible for this, because he saw the power of using radioisotopes to map out the path, the metabolic pathways. So now let me generalize this, right? And so you start off with a radioactive substance A, That was CO2 in Andy's case. And then you get your favorite biological object. That was the suspension of algal cells in Andy's case, but it could be E. coli, it could be yeast, it could be lobster tails from Alaska, or salmon, or beef hearts, or whatever. All right? And so now you expose this, your favorite biological object, to substance A, the radioactive substance, for some period of time, 5 seconds or 5 minutes or so. And after that period of time, you stop the reaction and you break open the cells, and now, instead of having just one radioactive substance, you have many. And the task in hand then is to identify B, C, D, E, F, and G, right? So that you can construct the chain of events that occurs within the cells. Now, when Andy started doing this, nobody had used radioisotopes in this fashion before. And so Andy set about to do this, and I'll call this Benson's protocol. All right? Because not only did this lead to the elucidation of the path of carbon in photosynthesis, now known as the Benson-Calvin pathway, although I'm not entirely sure what Calvin did. But one shouldn't, it's a mistake to think that Andy's legacy was confined to the path of photosynthesis in plants. Because this Benson's protocol was subsequently adopted. And in the golden age of metabolic biochemistry, all sorts of metabolic pathways were worked out. The pathways to fatty acids, to sterols, to terpenes, to purines, to pyrimidines, and so on and so forth. And if you look at all of these papers, you can't help but concluding is that these guys are actually just applying a variant of the Benson protocol over and over and over again. And so that's why the textbooks now are packed full of these pathways. Now, I should say as an aside that I'm not sure that the undergraduates of today altogether appreciate all of this surfeit of information that they are required to memorize. However, so I think Andrew's legacy can best be summarized in the words of Isaac Newton. He enabled us to see further because we stood on the shoulders of a generous and gentle giant, Andy Benson. Now, I want to conclude with a little anecdote that casts some perspective on another aspect of Andrew Benson, and that was he was enormously modest about his own accomplishments. And when I got to know him a little better, I noticed that whenever I sort of tried to get him to elaborate on some of the events in the Calvin lab, he would immediately change the subject and not want to talk about them at all. However, if you wanted to talk about the accomplishments of junior scientists, then Andrew Benson was unfailingly enthusiastic and effusive in his praise for what the younger scientists had accomplished. Now, I'll give you a little personal example of this. I didn't actually meet Andy until about 30 years ago, although of course he was actually one of my scientific heroes. And I came to UCSD to give a seminar and on my work on Rubisco. And the seminar started, and about 5 or 10 minutes later, I noticed this white-haired gentleman slipping into the seminar room, and sitting amongst the graduate students at the back of the hall. Now, this was quite unusual for me because professors, in my experience, generally march right up to the front of the class and take the seats at the front. That wasn't Andy's style at all. He simply slipped in there unobtrusively and sat amongst the graduate students. But I do remember very clearly that when the seminar was over, he rose and made some very kind remarks about the work that I had done. Now, I can tell you, I guess I must have been about 42 at the time. You can imagine, as a 42-year-old scientist, here you have one of your scientific heroes praising the work that you've done. I tell you, it doesn't get much better than that. But this this is not just a general phenomenon, a specific phenomenon. This has been told to me by Andy's legion of admirers and friends world over, that Andy was always unfailingly generous to his colleagues and younger scientists. Now, just recently, some of you may have seen the video that Bob Buchanan made with an interview with Andy. It's a very interesting video. I can give you the YouTube address if you don't have it. And very recently, Bob Buchanan retired after 50 years on the faculty of UC Berkeley, and Andy, true to form, was it last year or the year before perhaps, has made a nice little addendum to that interview where he praises Bob Buchanan's contributions to the University of California and so on. Typical Andy Benson, age 96, he was still willing to enthuse about the science of others. So I'll conclude by raising the toast to the spirit of Andy Benson. May there be many more with broad shoulders upon which the next generation of scientists can look further, as Isaac Newton did some 400 years ago. Thank you.